think we'll go ahead and get started with our first class for today, which is Mass Wall Masonry in a Modern Context with Austin Tunnel. Austin is the founder of Building Culture, a design and build firm based in Oklahoma that specializes in solid load-bearing masonry in new construction and historic restorations. In 2013, he began his career in building by relocating to Panama to work with Kaluyala and building a sustainable new town. There, Austin was introduced to Clay Chapman, whose US-based company, Hope for Architecture, has been building solid, load-bearing masonry structures for nearly a decade with the mission of rescuing the values and wisdom of the past in order to contribute to a lasting built environment today. Austin spent 2 years training under this master builder, and upon the completion of his apprenticeship, he founded Building Culture. Since then, Austin and his team have continually pursued projects with a mission to support environmental sustainability and community well-being through the use of traditional building materials, methods, and craftsmanship. Everyone, please welcome Austin Tunnel.
All right, well, thanks everyone for joining me today. Thanks for the introduction, Julie. My name is Austin. And I wanted to talk about how traditional methods and materials, namely mass wall masonry, can play a role in creating a more beautiful and durable architectural legacy here in the United States. But first, I'd like to start off with a few observations. Americans love to travel, including myself, and we're willing to spend thousands of dollars just to experience beauty in another part of the world, even for just a week. And many of these places are not untouched wilderness, but are, cities and towns and neighborhoods, places created by humans, and are some of the most beautiful places on earth. Yet when we come home, we simply accept the world around us, the suburban neighborhood without trees, the soulless strip malls and parking lots and massive highway intersections the size of small cities. And it just seems normal to us, or at least such a seemingly insurmountable problem that it's hard to know where to even start or, to go about changing it. But to me, I think that requires going back to the why. Why do we build? What is architecture for? To me, the answer to that question is simple. We are building for humans. We build in order to create a flourishing world, a thriving world, a world full of beauty and harmony and stewardship. And yes, there are many variables and constituents involved in architecture, but ultimately, we're not building for banks or building codes or governments or GDP. We're building for people. And that is our inspiration and our cause. And I think it's extremely difficult to keep that in mind in our profession because just about everything out there seems to pull us in a different direction. And you can see the outcome of having lost sight of the why. In the United States in particular, I think we tend to think of any building and development as a destructive force rather than a regenerative one, something that can enrich the world around us. We think that way for a lot of good reason, to be honest, based on what we've been building over the past century. We tend to think of buildings and development as destructive forces. And to me, part of the problem is, this is actually a really interesting slide of, just seeing the example of terms of scale of Sienna, overlaid over a highway intersection from Houston, which is actually where I'm from. But to me, part of the problem is that in the United States, we tend to think of building so individualistically, as if the building itself is everything that matters. But like a mosaic, buildings interact with other buildings and they work together. And at least have done well to frame and create other meaningful spaces, the spaces between the civic realm. And you can see the difference on the caption on the left and then the right of a typical suburban neighborhood with cul-de-sacs and an old European city where you've got the negatives and all these spaces that these buildings create. Now, thankfully, the new urbanist movement, really starting with Seaside, has brought a ton of attention to this way of thinking. And have been true pioneers, treating our neighborhoods and towns and cities as complex ecosystems made up of individual pieces that interact with each other, as well as bring attention to human-centered design. And over the past 40 years, that philosophy has been making its way back into governments and municipalities and academia and even into mainstream thinking. So as that fight continues, and we still have a long ways to go, I'd also like to draw attention to another aspect of architecture that is essential if we want to build great towns and cities and neighborhoods again, and that is beauty and durability. So I just want to share a little bit about my work, but first I want to give a little bit of background of who I am. So I started off actually as a CPA in Houston at a large accounting firm about a decade ago, and not being super satisfied with that, I left and explored and went to Panama, which is where I was first introduced to new urbanism, and it really struck me having grown up in the suburbs of Houston, it just all made sense reading the tenets of traditional neighborhood design. And I happened to, while I was there, I met a guy who'd been experimenting with mass wall masonry. So after doing some other stuff and going out to the Peace Corps, when I got back to the States, I called the guy up and asked if I could apprentice for him. And he said, yes. So I moved to the middle of nowhere, Oklahoma, well, Carlton Landing, and worked for $12 an hour for 2 years in my late 20s, working, doing hard manual labor. And the reason I like to emphasize a little bit about my background is because I don't have a design background. I don't have an architecture or even really an artistic background. And the reason I like to emphasize that is because the way I build, I taught myself design just by drawing buildings in SketchUp late into the evening, many nights towards the end of my apprenticeship. And I like to emphasize how simple my buildings are, how the stuff that I'm doing is not difficult. It's not hard. It's not rocket science. It's not even that skilled. I'm just building rectangles with authentic materials in good proportions. But anyway, towards the end of my apprenticeship, I had gotten in touch with another builder and an investor that basically help me set up my first project, which I'm going to play that video for you. So this is a pocket neighborhood in Carlton Landing that we built. We bought 3 lots divided into 6 houses around a common central courtyard. And as you can see, we've got 4 structural masonry houses, and we've got 2 shingle houses that my business partner built. So this is a lime wash on the walls too, I should say. So rather than like a latex or oil-based paint, we're keeping the natural materials and a breathable, vapor open, lime wash on the brick. It's a moon gate in the back into a more private courtyard area. I really love creating spaces with buildings. And brick is such a good medium to do that with. So many details, like simple details like this that are easy to pull off with brick. Every brick is an opportunity to, have some shadows and interest. And we do lots of heavy timber stuff too. But anyway, I'm not going to play the rest of the video. So why mass wall masonry? To define it specifically, they all really refer to the same thing, and that's the practice of using brick or stone in such mass that it becomes self-stabilizing or self-supporting, unlike a veneer that has some kind of substructure. It's got wood frame or steel frame substructure, and then the masonry is a veneer. Mass wall, the masonry is the structure. And we do see this in the United States, some with concrete block formations and stuff. But you might be wondering, like, why do I care about mass wall out of all the different ways? And to me, just looking, it's one of the oldest and most resilient building practices. All of the oldest buildings in the world are built with load-bearing masonry. From the periods or the Parthenon to the Pantheon to the Taj Mahal to the Biltmore, all of these buildings have stood the test of time, along with entire cities that are centuries old, all built out of mass wall. And that system of building that was the product of thousands of years of human progress and evolution was essentially replaced overnight, with advent of lumber mills and mass-produced nails. And while there are obviously some great advances in building technology in the 19th and 20th century, I have some serious concerns about the durability, the health and environmental impacts of modern building systems. And I don't mean I think we should go back in time and build exactly as we did 200 years ago. After all, most traditions were once considered modern. I mean, one way I like to say it is tradition is proven innovation. So to me, it's about blending the best of old and new. But I do think we have a lot to learn from the past, from time-tested traditions. And when I look at what is being built in the US today, I think we're missing the mark in a lot of ways. So my aim with exploring mass wall is to make buildings from authentic, durable materials that will last generations, and that will contribute to the fabric of beautiful neighborhoods, towns, and cities over generations. Just a few pictures. So this is part of the Bend. This is a little 1,800 square foot house. There's about 60,000 brick in here. We've got these stone lintels that we'll see a little bit more of later, timber framing porches, and like I said, a lime wash, cedar shakes on here. This is just an inside. If you can see how a brick interior can be really updated and have both the combination of kind of a rough feel, but also more like modern feel too, with the white and stuff like that. And here's another example. You've got this more modern feel where I'm still bringing some traditional, or some stained wood and stuff like that. And then also just a straight up exposed brick interior, kind of, feels like a New York loft or something like that. So I actually wanted to go over my basic building process, and I'll do it pretty quickly, but just kind of show you what I'm doing and how I'm doing it. Footings. Really simple with mass wall buildings. Of course, it depends on where you are and if you're working with elevations and all those different things. But for the most part, we're just doing monolithic earth form footings. We dig out the footing, we pour the concrete, and then we start our brick right on top of the footing. You might be looking at this footing on the left here and saying, there's no vertical rebar sticking out of it. We end up epoxying rebar in exactly where we want it. We drill the footing, put the rebar in. It just makes it easier to get it exactly where we want. There's nothing special about these footings or the foundation of these mass wall buildings, except that they tend to be wider than a stick frame house to distribute all that weight, because masonry doesn't have any tensile strength. So any movement, the masonry is going to crack. So I tend to make my footings pretty wide because it's really just concrete. It's not a whole lot of money. So for example, these footings are 4 feet wide and only a foot thick walls going on top. Once we get the footing poured, we put our leads up. So if you see the picture on the right, there's this pole with these little outriggers on here. We put those up, and then that's what we put our strings on and start laying our brick. And you can see here, I've got this little L bracket. It's kind of hard to see, it's a little blurry, but I've got this little L bracket lets us put a string on our inside wall, right? So that way I've got a string on the outside and the inside. This is a wall section. This is what you call a triple wide wall. So you've got 3 layers of brick, each about 1 foot thick in total. And you'll see the interior brick, the inside brick, the middle brick, I should say, it looks a little different. And that's simply because I'm using cheap brick for the inside. It's not a structural issue. One brick's not stronger than the other. It's just that the brick you're going to see are 64 cents a brick, and that interior brick is 30 cents a brick. So I save money wherever I can. And actually, when I know I'm lime washing a building, I also use the cheap brick because it'll save a lot of money. It's half the price. I'm laying in what's called common bond. There's different bonding types for brick, but it's really just referring to your header courses. Header courses are, as you can see, the brick laying the other way that's tying the different whites together. And this is how you know if a building is structural masonry. If you're in an old bar or coffee shop or something, you're looking at a brick wall. If all the brick are the long side, they're called stretchers. I don't think I don't have a good picture of it, but like in a veneer netting, there's no use for headers because you're not tying any other whites together. So on this one, we're tying these whites together, and then you lay another one on top on the other side. And we do that every 6 courses. And that's why it's called common bond. There's different bonds, Flemish bonds, English bonds, stuff like that, where you might go stretcher, header. But here we do 5 stretchers, 1 course of headers, 5 stretchers, 1 course of headers. And we do that because it's fast to lay. So we also use stone sills. There's a couple of reasons we do this. The sill area under the window is the weakest point in, well, probably most buildings, but also in mass, that stands true for mass wall masonry as well. So if you just lay brick as your sill and you've got all these exposed mortar joints, that's allowing water into your wall. Now, brick is a vapor open system, so it's always absorbing and releasing water, yes, and you don't want to seal it off, but you also want to keep as much water out as possible. That's why we strike our joints on the outside of it. But these stone sills, and you see a lot of precedent in this in old downtowns and stuff like that, is that's what they are for. There's no mortar joints. They're a solid surface. We cut this slope into it so it sheds the water and keeps the majority of the water from ever even getting in the wall to begin with. And these are through wall sills in this context, so you can see that sill, on the inside as well. Window bucks. So after we place our sill, so this is us placing our stone sill, then we come in here and I have these pre-manufactured, I say pre-manufactured, I have someone make them. These are called window bucks because I put them up just right on top of my sill, and these are the rough opening for my windows. I build my brick around it, and then literally at the end of it, I just get new construction windows with flanges and just screw them in. These don't go out. A lot of people think like I put these in to lay the brick around and then I pull it out. I leave these in. There's a couple keys to leaving them in. Is on this picture right here, you see this membrane. It's because anytime wood is touching masonry, I always put a membrane on it to protect the wood because masonry carries water and moisture, and you don't want that touching your wood. So any wood connections to my masonry, I always have some kind of membrane. And also you see these little galvanized carriage bolts sticking out because that basically just gets grouted into the wall as I lay brick around it and secures that buck inside the wall system. This is just showing how I reinforce my buildings. This one over here on the left, the horizontal is called the bond beam. So we just leave our middle wipe out every so often, typically above and below windows, directly below and directly above windows, which is actually not too cumbersome because if you think of a normal 2-story house, we'll lay 4 bond beams. We'll lay directly below our first set of windows, directly above our first set of windows, and then the second story, same thing, below and above. So we pour grout into here, and then these are our verticals. This box right here, we just make it on site. As you can see over here, that keeps the hole really, really, really clean. So then when we go to fill it with grout, we only fill it when we're filling the bond beam. So we're building, we're laying brick, we're sliding this little sleeve up. And then when we go to pour the bond beams, we just pour all the verticals and the bond beam at once and then keep going on top. Just some photos under construction. So you can see the windows and the bolts and the rebar coming out. And we actually scaffold from the inside a lot. Some people give me a hard time about that, but we found it to be easier, safer, logistics easier. So, and this was also like a 50 or 60 foot tower. So another important aspect, masonry is almost all about creating leads. So this over here on the right is a tapered column, so all we did was create some wood scaffolding and then pull strings down. And then we just get to layer brick. For example, over here on the left, I'm putting up a gable lead, which you will see right here. You might be able to see these strings. I don't know if it's coming through on y'all's computers, but like I've got these strings and this represents the gable. And you can see the gable going up here on this build over here. The basins are just laying up the strings. So some people wonder too, I should say that, is this really possible for anyone else to do? Or does it take someone specialized knowledge? But I've gotten to the point where I'm very rarely ever laying brick myself. I used to, and I used to have to do things to kind of show my crew. But now that they've been on 10 builds with me or so, they are so good at it that really all I do is kind of show up and make sure the gable leads are right, make sure the windows are in, being put in the right position, because it's not like a stick frame build. If you put the window in the wrong position, it's going to be in the wrong position. There's no moving a stud over. So it's really more of a management thing than a skill. Just showing some arches. This is a passage right here, so it's not like a window buck I have in. This is going to come out. This is going to be temporary. But as you see, we just stick this in, lay our arch over it, and we always do several voussoirs rather than just one, or row locks. 1 for strength and 2 for aesthetics. Roof connections. So on most of my builds, I've got a big structural ridge beam spanning. So this is like a triple LVL, like a triple 24-inch LVL or glulam or something. And I just pocket it into my gable right here. And that's the structure of the roof. And I basically just hang my rafters from that. This, I don't have a great picture of, but this is my sill plate. So imagine the eave height of the brick wall, it tops out. And then I've got to figure out how to connect either a dormer or my roof system to it. So I lay down the treated 2x12. Well, these bolts, I'm sorry, I grouted in when I was pouring my very last bond beam at the top. I stuck these bolts in and grouted in. So these bolts are embedded, 6, 8 inches into that wall. So it's an extremely strong connection. And then as you can see, just hanging my rafters from it. So this is what it looks like when you've got all the brick up. We've got our LVL, our ridge beam in, which we kind of later in the masonry. And this one, because we had a parapet going above, we just bring a framing crew in afterwards. Floor connections. I also wish I had better pictures of this, but if you can see here, I've got these brick corbelled out right here, where you've got 1, 2, 3, 4 corbels, each about 3/4 of an inch each. So it creates a 3-inch ledge because I corbel out 4 courses and then I go back to my normal wall. So it creates this ledge that I can set my floor system on. Like I literally rest my floor system on that. I still drill it into the walls. Some people think like, wow, you're putting a lot of weight on those brick, but because we're corbelling out slowly, 3/4 of an inch each, no more than an inch, it might be 3/4 of an inch to an inch. There's a little bit of tension, but it's basically all in compression because you're just stepping it out. You could put so much weight on that ledge, it's crazy. So that's what's kind of cool about working with mass wall and the ability to use structural corbels and things like that. Let's see, interior framing. So once the masonry is up and we've got a roof on and stuff and floor systems, the interior framing is just like any other house. We come in and we just frame it up and butt it up against the wall. The only special thing we do is, this stud right here that's against the brick, even though it's completely interior, we still just go ahead and put a membrane on it. We just make it common practice, any wood touching brick membrane. But other than that, this is completely conventional framing inside the house. Something else that's pretty cool with mass wall masonry is just connections. In stick frame building, waterproofing and flashing, can really be complex issues, which is actually one of my concerns with stick frame in terms of hypothetically, you can design something to be waterproof-ish, I guess. But in the field, is it really being implemented that way? I kind of have a philosophy that you can't actually keep all the water out of a building. Water is always going to get in. So how are those materials going to, work with water, which is one of the reasons I like working with stone and brick, where you're still trying to keep the majority of water out, but it can handle water. It's not damaging it like it does spray foam or 2x4s or sheathing or something with a bunch of glue in it. But anyway, so these connections, I'm attaching this second story porch to my house. So first off, I have these structural corbels where I basically just rest the porch on it. And that is really carrying all the weight. They're actually resting on that. Then you can kind of see it in here in the corners. I've got these bolts right here that I've just drilled through. This is like an 18 or 20 inch bolt because it's going through the 6 or 8 inch wood member and then all the way through the wall to the inside of the house. So this washer right here is the inside of the house. It's just all the way through. And so you see that. This is kind of a cool washer, but we've done some decorative washers, where we get some like a fleur-de-lis cut out of sheet metal, and that's the washer. So, it's cool how these structural elements can end up being really beautiful, just like these corbels. They're serving a purpose, they're structural, and they're also beautiful. And so I do a lot of timber framing, though. At this point, this, for example, is not a true mortise and tenon timber frame, like where we're mortising it out. We are, as you can see over here, we're notching it out for structural purposes, but I'm not doing a mortise tenon dowel rod, mainly because of cost. It would taken me 4 times as long, and really these two guys in this picture built this entire porch with me kind of overseeing and managing it, versus a timber frame would have cost 4 times more, a true timber frame. So that's what I'm saying. I'm calling it quasi timber framing because I still notch it out and provides that structure, right here. And also very pretty, and provides kind of the aesthetic too of being timber framing while still being somewhat cost effective. A lot of people have questions about, okay, that's great that you're building this mass wall stuff, but what about energy efficiency? It's a great question. So one, it depends where you are. I would never build uninsulated mass wall masonry in a cold climate. I'm in climate zone 3 in Oklahoma. Brick mass walls do not perform well in very cold environments. They do perform well in warmer environments in places like, New Mexico and Arizona and things like that, where you've got large swings between day and night temperatures. So it actually works pretty darn well in Oklahoma. But at the same time, for me, for this to be a true alternative to conventional building, we've got to figure out a way to insulate it. These are pictures from something else of a hempcrete. This is from Belgium. These are hempcrete blocks, basically in between 2 brick wall systems. Now, I'm planning on doing mine differently because I don't like, maybe on a single story house, something like this where you've got 2 skinny brick walls, but I'm working with University of Oklahoma to test out a wall system where rather than our normal triple wide wall, we're taking a double wide and separating out the double wide and then a single wide, and we're going to have rigid mineral wool panels in between. Or hempcrete. I think there's a lot of stuff to explore. The problem with hempcrete right now is it's not being produced in the US. We're having to import it from Belgium, and it's just extremely expensive. Thankfully, there's actually a firm, Hempitecture, that's starting hemp manufacturing facility in Idaho to be the first, true building grade hemp production in the country. So I'm really excited about that because hempcrete is another vapor open material. It's super insulative. It's like 3 to 3.2 R per inch, and vapor open. It's just hemp hurd and lime. So that's an exciting building technology that I think will end up being part of what we do. There's a few different applications. One, blocks like this. Another option is to just spray it on. So I could imagine you could take my exact wall system that I have, that everything I just showed you, and then spray 3 inches of hempcrete on the inside, which is actually the easiest way to apply hempcrete. There's no one in my area to do it. That's why I haven't done it yet. But you could build everything just how I build it, spray a few inches of hempcrete over it, meet all the building codes, and then you just plaster over it with a lime render, which is beautiful. Anyway, just a little plaster veneer. So there are multiple things I'm working on. And actually this year, we should be breaking ground on that concept I was talking about with combining mass wall and rigid mineral wool panels. So just wanted to offer a few kind of practical tips. Brick is an amazing material. When building with mass wall, it's more like sculpting than anything else. Each brick is a pixel, an opportunity to provide, a little interest or detail or shadow line. The brick is the size of the human hand, right? And then it's sized to fit the human hand. And then when a house has 60,000, 80,000, 100,000 brick laid by hand, you get this very just human feel that you can't replicate in anything else. And with mass wall, it gives you the opportunity to create real depth. That's part of the problem with our modern building system is everything just looks like it's stuck on because there's no depth anymore. And by the way, I'm saying this like even as a facade or veneer, you can still use brick to create that depth and visual interest and shadow play. So here's some examples of, I've got pilasters on this building, which are one serving a structural purpose and also they're beautiful. I've got these corbel out to a termination front here at the eave, all this little toothing, which yes, this stuff is time consuming, but it's not hard. Most masonry crews can pull stuff off like this if you show them. And I don't mean you have to be able to lay the brick yourself. I just mean show them how you want it done and they can do it. And it's really easy to create some beautiful stuff like this. So yeah, just what could be a hardy plank tower turns into something very visually interesting. Just some other examples of corbeling out at the top, some toothing over here. I mean, even every arch is an opportunity for detail. We always do a few voussoirs and corbel out one or two of them. These are going in and out. And none of this is very time-consuming stuff. It's not stuff that adds a lot of cost because they've already got to build the arch. I also tell people like there's a kind of some simple ways to incorporate brick structures into landscaping. I just built this in my backyard. It's kind of an ugly picture because I've got the fence and stuff behind it. But yeah, this is super simple stuff to build. This is probably 1,000 brick or something like that a masonry crew could knock out in 2 days. And like I said, simple detailing. The moon gate was a little harder, but still a lot of bang for the buck. It wasn't that difficult or expensive. And it's kind of iconic in the area. Like people come by and take prom photos and wedding photos and things like that. So incorporating just some of these powerful, hard-hitting architectural things into our buildings and neighborhoods and developments really makes a difference. Or a little courtyard area. This is just a design for a pavilion I was playing around with. I have not actually gotten to build this. It would be very fun if I did get to build this. This was for Carlton Landing. Just dreaming about using mass wall in some other forms and contexts. And then I wanted to point out again just how accessible this is. I said it before, but these three guys that you see in this picture are 3 Notre Dame students that came down in January of this year, 2021. And I was very busy and I didn't have the time that I wanted to work with them all day. So we, rather than just kind of leave them on the job site where we were laying brick, I had them lay brick with us for a few days. And then I was like, hey, why don't you guys design, a triumphal arch? So they designed a little triumphal arch. And all I did was I helped them set it up with these poles and I poured the footing. I helped them set up the poles and then I laid the first 2 courses with them. And then that's it. These are people that have never laid brick before. And by the way, this is not done, but I was just astonished at what they were able to accomplish. 3 guys, not a construction background, never laid a brick before. In a couple of weeks, they built this. So I think this is such an accessible medium. It's just been kind of forgotten. And a few more practical thoughts. Whether in a mass wall setting or a veneer setting, just using traditional materials, it's so important to use the right brick. And what I mean by that is this brick on the left, and this brick it's not a great picture because I left it in the back of my truck and it kind of got beat up. So the sharp edges have been taken off, but that is an extruded brick. It's a cheap brick. It's a 30-cent brick that I put in the middle. If I were to build my whole house with this, brick can go from being a very human, earthy, warm material to very cold and sterile very fast. Prisons are built out of brick too. And it's all about the sharpness of lines. You've got perfect brick and you've got perfect mortar joints. You're going to get a kind of an impressive feel. So I always try to use, if I'm not going to be painting the brick, some kind of tumbled brick. This is a general shale brick that I get out of Denver, 64 cents a brick delivered, but it's beautiful. I mean, it's the closest to a reclaimed brick or a true wood molded brick that you can get at half the cost. Something that I see in veneer settings that often drives me crazy is people will, this is my building, but we've just laid one across here so far, and we're about to lay two more. I always do at least two. When people just do one, and I'm calling these voussoirs, but someone could probably argue with me about whether, because I'm not gauging my brick. Oh, that's one thing I should say too, is I'm laying rough arches. And what I mean by that is if you look at this arch, I'm not cutting my brick. If you look at more formal buildings, more classical buildings, you'll have gauged brick is what creates the wedge. I'm laying what's called a rough arch because it's about 10 times faster, which means 10 times cheaper. It's extremely time consuming to cut every brick to an angle. So we're just laying our brick over there and letting the mortar be that wedge, be the joint. So it's a very fast and economical way of laying an arch. The only thing you've got to watch out for is your radius. If you start getting a really small window or opening or something, and say you did a Roman arch or a half round arch, you would have these giant mortar joints that would look kind of funny. And that's the only thing you got to be careful with rough arches. And I always say, just lay at least two and it makes all the difference visually. And like I said, lay a little messy. Like I actually have to work with my masons to not make the mortar joints perfect because they want to make it perfect. And that's how they've kind of been trained. And that's kind of their way of thinking about what makes a good mason. For me, I don't convince them to make it messy on purpose. I just say, lay fast and then don't take the time to go back and make it perfect. We still strike our joints, but we do it with a different tool that's just kind of packing it all in, but leaving that kind of messy, organic feel to it. This isn't a great example because I don't actually have a lintel above, but a lot of times, I'll see stone lintels that literally don't span over the window and into the brick. They just kind of literally in line with the window. So they obviously can't actually function as lintels. So even in a veneer setting, just getting some of those details right. And I'm wrapping up here. So in closing, I just want to read something that I had written for an article. When I say towards a new building culture, I don't mean storming the barricades of the current institutions and power structures. I just mean taking action in our own spheres of influence to create compelling alternatives and to remind people that humans don't have to be destructive forces. They can cultivate and they can enrich. And as we change the culture, policies and institutions will follow. It's not about a particular style or replicating, some classical order precisely, but about the continuation of the classical tradition, which ultimately is a value system, a system that values beauty and harmony and stewardship and celebrates the infinitely creative human spirit. And those values bridge across all places and cultures and economic statuses, yet express themselves uniquely in each because humans are amazingly diverse and inventive. And when we take those values and express them in a durable architecture, we not only enrich the world we live in, we preserve and perpetuate those values, allowing posterity to build upon our accomplishments rather than having to overcome them. And that is it.
Fantastic work. Thank you so much, Austin, for sharing your presentation with everyone. I think it was just wonderful. So actually, we already have a question in from Manuel, who says, I've been sold on this way of building for many years, but it seems the only way to meet the energy codes, he says R49 on the roofs and R20+5 continuous insulation, is to do some kind of hybrid construction, and therefore it's not really possible to do a real mass wall. What are your thoughts on that?
Yeah, so I think largely I agree, except for example, I'm looking forward to hempcrete becoming more widely available in the US. It was really kind of resurfaced in France. They found it in some 6th century bridge abutments, and the French really kind of pioneered it in the 80s to help insulate all of their existing buildings. So that's where I say, I think you could take a building without adapting the system that I'm doing at all, taking the system I have and then literally spraying hempcrete on the inside, and you're still getting a beautiful, yes, right now, I think because it's really nice to have that exposed brick on the interior, it kind of tells a story, but having hand rendered plaster is also amazing. You still have all the arches and you've got, so I think that you could absolutely meet energy code by taking a mass wall system, spraying hempcrete on the inside, and then lime render plaster over it, and you'd have a very continuous insulation building, highly energy efficient, plus the thermal massing, and it would be really great. The alternative is the option that I talked about, and I wish I had put up a wall section of what we're working on, but like I said, we're kind of combining, or we're still doing mass wall because I'm doing a double wide wall that's still structural. Yes, but I am using that and then leaving a cavity with rigid mineral wool and then another layer of brick on the inside tied together with these basalt reinforced ties called Teflo ties. So that is a hybrid. I'm curious to play with that and see, and do testing over the long term. But I think there's quite a few options out there to do true mass wall buildings. I mean, even Vitruvius has, he's got writings about cavity walls. Now, their cavity walls back then were really two mass walls with a cavity in between. But yeah, I think it's something that's going to take innovation, and the more people thinking about it and testing things out, the more we're going to discover. So
another question coming in from Sasha, who asks, how do you address the stone lintels being an energy and heat bridge?
I would say every house, if you were to spray hempcrete on the inside, that would kind of solve your problem because it would cover the stone and still provide insulation. I guess what I would say too, though, is that every building has thermal bridging of some kind. Now, I know we're getting really creative with trying to avoid that, but we're also making our building systems far more complex. And I still question how well they're being pulled off. But I guess the simple answer is I don't worry about it too much. Just the thermal bridging of some stone lintels is just not going to be a big impact. And the other thing, as we're on the topic of energy efficiency is absolutely important. And it's something I think about, and it's something that I think we're going to have to make these buildings more energy efficient to be feasible long-term. At the same time, I think the industry overall and the building code's kind of obsession with energy efficiency is a really bad, harmful, unhelpful maybe tact. It's because it's one variable of many. Like architecture, it's about human thriving and human well-being, and lots of values fall within that. Human, energy efficiency being one of them. But I would like to also see a more holistic approach to architecture rather than just, is it energy efficient? Is it energy efficient? Because just imagine, what if we decided we didn't have to live at 70 degrees 24/7, 365 days a year? What if we could live with 10 or 12 degree temperature swings? What if we could live with 78 degrees in the summer and 66 degrees in the winter in our own houses? What would that allow us to do architecture-wise? Are we really going to completely replace the architecture throughout all of human history so that we can live at the same temperature all the time? So anyway, I'm kind of on a soapbox about the energy efficiency because I do think it's important, but that's still not what architecture is about, in my opinion. And not that I think you were suggesting that, by the way, just that the industry, I wish we could talk about other things. But anyway.
Jason has a question. Do you use a brick and mortar with a weaker design strength that allows the masonry to breathe better?
Yes, and that's actually another difficult thing in the US, because doing true NHLs like natural hydraulic lines, you got to import them from Europe, and it's like $50 a bag versus $10 a bag for just your type N from the store. So we have used just Portland lime blends where we've custom blended type S line with bags of Portland, so we know what's going in it. But on my next build, where we're doing this insulation, we're actually using a PHL pozzolanic hydraulic line it's out of Ohio. So it's like your 3.5, very, very soft type O, no Portland. They're using like metakaolin or something, I think, as the pozzolan to give it a hydraulic set. But yeah, so you can get lime mortar here. And yes, you definitely want to use softer mortar. A lot of masons and stuff don't know that, and they think the harder the better.
Kind of relevant question asked before what you were just saying in response to Sasha's question. Christopher says, do you think the move towards performance-based total system building and energy codes will encourage more mass wall construction versus prescriptive codes holding it back?
I think it could, except that there's still other things to take into account. So one, I live in a 100-year-old house. That's a stick frame house with a brick veneer. And it's in great condition. And I've had to think about this a lot. I'm like, man, this has held up really, really well. But as I've thought about it and realized that one, all these 2x4s that we built, it was built in 1930s, early 1930s, old growth wood. The sheathing is, old growth 1x8s, and there's no insulation in it. Then it's lath and plaster on the inside, and then a brick veneer on the outside. And so what I've realized is this house is a vapor open system. It's not a mass wall system, but it's a vapor open system. And what I mean by that and why I'm pointing that out is because yes, water gets into these walls, but because it doesn't have insulation and it doesn't have air, it's not wrapped to trap in all the air, those walls can still breathe, and that water can get in, it can dry out. And yes, there could be rot in some areas if there's too much water, but this house has been going 100 years and will probably could go another 100 if well taken care of, versus what we are building today. And we realized this about 20 years ago as we were kind of paying more and more attention to energy efficiency. As we were pumping more insulation into our houses, then we realized we really had to worry about air and stuff like that. So we started putting all these air barriers on. The problem is now our walls don't breathe at all. So if any water gets in, then you've got major issues because it can't get out. And so you've got people like, the Matt Riesingers and the Building Science Fight Club people that I follow who are really building science focused. And I love it. They're very, very good at what they do in advancing building. But when you're asking about performance building, it's like, I talked to a mold specialist who says there is an inverse relationship between the health of our indoor air quality and energy efficiency, as in the more our house gets energy efficient, the worse our air quality gets, because exactly what I'm talking about, when you turn your house into a refrigerator, you've got all these products with VOCs and glues and water that gets trapped, and spray foam holds it like a sponge and molds. You're creating all sorts of problems too. And we have not seen those problems yet. Not really, these buildings haven't been around long enough. So when we say performance modeling, if you were to take into account a lot of other things over the long term, I think, yes, you're going to see a lot of rethinking of how we're building, but I think it's going to take time to recognize we're kind of just doubling down on what we're doing and tripling down and just keep trying to go down the same path and fix it by making things more complicated. And I think it's going to take a while to kind of swing back the other way, my personal opinion.
Austin, then the next question, Thomas asks, is there a benefit to using solid brick instead of brick with holes?
Good question. So yes, if budget was not an issue, I would use solid brick all the time, but not because of the structure. Structurally, virtually no difference in a cord brick or another brick. I mean, if you were to like smash it, sure, it would break differently. But I mean, in the context of a building, there's no difference structurally. But what having solid brick does is more mass for water to absorb and then release, rather than having all these little pockets and stuff. It's just probably a little bit better. So sometimes when we use reclaimed brick, it's all solid brick, but it's just not feasible cost-wise most of the time. Although one thing you could do is you could just say do the outside in solids and then use cord brick on the inside.
Elizabeth says, can you talk a bit about coordinating with electrical? I'm assuming you just keep HVAC and plumbing off the exterior walls.
Yes. Particularly, for example, if I'm building a small rectangular house, for the most part, the downstairs is going to be all brick because it's living, dining, kitchen. So there's really not a lot of partition walls, so it's mainly brick, maybe a wall around the staircase or something in the powder room. Upstairs, everything is partition walls between the rooms. So most of that electrical upstairs is just in a 2x4 or 2x6 wall. When you are doing it on brick, we just do exposed conduit. So you've got this conduit right here running, not the pendant I'm looking at, but the sconce behind it. I've got some conduit running down from the floor system and I'm mounting it to the wall. So it's just exposed conduit. And for my other mechanicals, in my second story floor system, I'm using open web trusses, like 20-inch open web trusses. So we run our HVAC through there, electrical, plumbing, all that kind of stuff.
Thank you. And the last question we have, I think, is kind of a good one to end on. Jason asks, without spending 2 years apprenticing, how can we start to learn these hands-on techniques and do some experimenting?
Good question. A little bit goes a long ways. Actually, I get emailed regularly like, hey, do you have any good books to read? And I'm like, nope, I don't, because no, there aren't any good books about it. It's actually really frustrating. Those Notre Dame guys that came down for 2 weeks, their competence level went from 0 to, to much higher, even though they're not like good bricklayers. It's informed how they think with just a little bit of hands-on experience. Being around the job site, little hands-on experience will go a really long ways and inform even the questions you ask. So I think that's what I would say is, I know there's not a ton of people doing it, but if you can find someone where you can visit, walk through a job site, ask questions, lay a little bit of brick, that'll make a big difference. Talk to some masons.
Absolutely. And we've had a couple people chiming in with the same thing I was going to say, which is perhaps a book can be next up on your list, Austin. You can take the
If I ever put this presentation,
Yeah.
I sent this presentation to Julie 5 minutes before. So
It's the makings, perhaps, for your next project.
Actually, what I would like to do is in the next year, hopefully, start doing workshops, like annual workshops. Hopefully, end up, I want to do more, but starting off with an annual workshop. And then also, I'd like to put out actual videos and content about it, especially as we develop our method with insulation that can be replicated in other climates. I really want to share that. So it's a priority for me.
Awesome. Thank you, Austin. I think we're at the end of our questions for now. But really appreciate your time. This was a really interesting presentation. And thank you again as well to everyone who submitted questions at the end. A really lively discussion.
Thanks, everyone.